So a program is essentially a set of instructions that a computer can follow. And these set of instructions are read by something called an interpreter, which goes through it line by line. So I can do something as simple as 1 plus 1. I can press F5, and well, if I'm using idle, and that will, well, it won't output it. I have to print it. And I'd encourage all of you guys as well to have a console open and follow along as I'm writing this stuff, just so you're getting hands-on experience.
Yeah, it's all about practice, getting good at programming.
So yeah, essentially the program runs through each thing and it evaluates each statement that you give it. And all programs are essentially just composed of many of these statements that you can do. So we'll begin with an introduction to variables. And what I've done there is I've done hashtag variables. And what the hashtag does, it's called a comment. And all that is telling the interpreter, ignore this line. It's essentially there for us to be able to label our own code and read it without changing our program. So I recommend all of you, comment your code, because it will really help you when you refer back to it to understand it. So yeah, so there's a few different variable types. There's integers, which are basically whole numbers, which are rounded to the nearest whole number. There's something called floats, which can take values anywhere, which can take any real value, essentially. So you can have 2.3, etc. There's something called a string. I'll call mine st, and that's basically a series of characters. So I can say st equals, this is a string. And the good thing about having variables is that it allows you to manipulate numbers without having to define them. So in the sense that I can now, rather than every time, let's say I want to print a number, and I can say that this number 2 here represents something that I'm measuring. Rather than every time having to write print 2 or print 3, depending on what I measure, I can just write print I. And it will take that value in and it will print it. And I can do the same for st. This is a string. And I can also do operations as well. So I can do print I plus f. And that'll give me 4.4. But what you can't do is add or subtract or whatever on things such as strings, because they don't actually represent real values. So if I had a string which said f equals 2, for example, that's not actually storing the number 2. It's representing, it's storing a character, the character 2. So if I was to do print I plus st, it gives me an error because it says unsupported operand, meaning I can't add an integer type and a string together. Oh. But what I can do is I can just have something called st, for example, and I can say st1 is equal to, and that's another string, such as I can even do something like my name is, and then st, I can say Haroon. Now, if I do print st1 plus st, and I run that, I should give me an output of my name is Haroon. So it's just added those two variables together. But so let's say that I want to print a string followed by a number. So I can say something like my age is, and age equals 20. So what I can do is print st, comma, age. And what that will do is it will print the first variable followed by the second variable. So that's how you can print two different data types together. Another thing you can do is you can convert between different types. So what I can do is, let's say I get my user to put in some input. That input will generally be in the form of a string. So let's say my user puts in, when I ask them for their age, they put the string in of 20. They put the two characters 2 and 0 in. What I can do is I can, let's say I want to predict the age, or just tell them the age they're going to be in 5 years. So I can do something like, your age in 5 years is, and I can say st of age plus 5. Oh, right. So, so the problem there was, as you guys just saw, I got that problem because I'm trying to add a string to an integer, like I just said. So what we have to do is do int, and then in brackets, put age. And what that's doing is that's taking my my variable called age, which is a string. It's turning it into an integer, which means now that I can perform calculations on it because it's actually storing the real number. So if I do that, your age in 5 years is 25. So some of you are probably wondering why brackets. You know, what does the brackets mean? And essentially, all programs are composed of variables, functions, and classes. So we've just covered, you know, the different types, a few different types of variables there are. There are obviously quite many more. So what are functions? So a function is essentially just like, if you've ever done maths, it's just like any function. It takes in a certain number of inputs, and it gives me an output. So if I want to define my own custom function, what I do is I say def space, the name of the function. I can call this function add 10. Then I can say it takes in, these are called parameters. The values that you put into a function are called the parameters of that function. So I can say def add 10, it takes in some variable that I'm going to call x. And then what I can say is return. So what is this function going to output once I give it this input? It's going to return me x plus 10. So once I've defined this function, what I can do is I can do something like add 10, and that's basically that's referred to as calling a function. So I've defined the function, and I'm going to call it, and I'm going to pass in, for example, 20. And I'm just going to say, I don't know, I'm just going to call that v, for example, and I'm just going to say print v. So what I should do is take the 20, add 10 to it, and then print it, 30. And yeah, functions are very useful because it allows you to essentially make your program totally modular. So you can essentially have, let's say I'm trying to make a program that's a calculator. So I can have a load of these functions defined, such as define multiply, define division, define subtraction, and define addition. And then I can feed in different values. So for example, I can say define addition, define add, and it takes in, to add you need two values. So I say it takes in two values, x and y, and then returns x plus y. So now I can call that function with, for example, the numbers 15 and 20, and it should add them. And one thing to note here is that the way Python syntax works is that every time you have a function, and because how do you know when that function ends and when it begins, right? So the way Python does that is once you wrote the define, it starts saying, okay, everything indented from here until there's no longer an indent is part of the function. So if I was to put, for example, that would give me an error. because that's basically saying you've defined a function, but you've written nothing inside it, because everything inside the function has to be indented by one tab. And I can do plenty more things in a function. I can even do, I can even make this function print, for example. So I can do a print x plus y, and it doesn't have to return a value anymore. Are you guys keeping along in terms of the tapping, or is that good speed?
Stop
Okay.
in like 5 minutes time. Ask a question.
Yeah. If you do that, so yeah, a function is essentially you can put anything inside it, and it will run that every time you call a function. And to call a function, the syntax is the parentheses, which are these brackets, right? So if you look closely, you can see that print is actually a function in itself, but we haven't defined it. What Python comes with is a load of functions that have already been defined, which allows you to do simple things that you might need to do all the time, such as it's a very, very common thing to be able to print the variables that you have inside your program. So print is one that comes preloaded into Python, and there's actually a whole list of these. What I'd encourage you all, get used to referring to docs and Googling things, because as a programmer, that's literally half your life. Because there's a lot of things, there's no need to memorize all these functions, right? Because there's no point. Anytime you need a certain function and you can't think what the name of it is, you can Google, Python function to do whatever you need. And this is essentially a list of functions that come pre-built into Python. Something like abs, that takes the absolute, that takes whatever number you put in, and it gives you the absolute value of it, so the magnitude of it. And yeah, there's a couple others such as sum, etc. So should we stop for questions?
Yeah, great, cool.
Cool. Yeah. Any questions? Yeah. Okay, cool. Yeah, if there's no question, then...
Do you know how to sort of run it on Mac? Not really sure. Never use Mac.
Run what on Mac?
Run a program through idle.
Oh, yeah, if you're on Mac and you need to run a program and you're using idle, you just click up here and you can select run module, where in Linux this uses the F5 button. Okay, cool. Let's move on. So there's another type of, so yeah, I'll just comment here. Functions. Oh, yeah. Okay, yeah, so I recommend use Python 3 from the start, because eventually at some point Python 2 is going to go out, because Python 3 is going to replace it. It's an updated version. There are some small differences. I'm not sure of all the differences, because I pretty much only use Python 3. So, like...
How can I combine it? Because when I write Python, then I put the name of the application. How the compiler is going to make a difference between Python and Python 3?
Yeah, so if you're running it like that way, if you want to compile it using Python 3, you do Python 3 space the name of it. Otherwise, you do Python 2 space. Cool. And if you actually use idle 3, which is the latest version, it runs automatically Python 3. Okay, cool. So yeah, we'll move on to something, another data type called lists. A list is, just like it sounds, it's a list. So we can say ls is equal to, and the way we define a list is using square brackets. So we say ls equals 1, 2, 3, 4, 5. And then we can say print ls. And that will print us the list. I'm just going to... Okay. And in lists, what you can do is called indexing, right? And the way you index a list, which means because you have a list, you don't always want the whole list. You want certain values inside the list. So what you do is you define in square brackets which indexes of the list that you want. So I can say print ls of, and the way Python works, it's a zero indexed, meaning you start counting from 0, and then so your second item would be would have index of 1, and your first item would have an index of 0. And just to make it clear, from now on, I'm just going to call it the 0th index, or the first item. So if we want the 0th item in that list, we can do print ls square brackets 0, meaning the 0th item in the list, and we just print that. It should print as that. We can also say, even though this this list has 5 items in it, right? If I want to get the last item, I'd use 4 because it's 0 index. So again, just to make that clear. And there's also, I can either do indexing like this, meaning start from the beginning because it's a positive number, or I can index like this. So I can say print ls of -1, and what that does is starts from the other end. So it will print me the last item in the list. And if I do ls, -5, shouldn't print me 1. And from the reverse direction, it doesn't seem to be 0 indexed. Okay, and so that's how to get individual items from a list. So what if I want the first 3 items? What I do is I say ls of 0 to 3. And what that does is it prints me the 0th, the first, and the second. When you're doing indexing, right, and you use this way with the colon, that means it's inclusive of the first index that you enter, but exclusive of the second one. So it will include the 0th, the first, and the second, but it will not include the third index. So when I print that, I should get 1, 2, 3. And we do. And so that's how you index lists, and that's how you can use basic lists. But there's also lists are a lot more powerful than this, because this is just a one-dimensional list. You can think of it as just a kind of a vector. So what we can have is, let's say, vec1 is equal to 1, 2, 3. Vec2 is equal to 4, 5, 6. And I can say ls equals vec1, vec2. This would give me an error, actually, because I'm using the variables vec2 and vec1 before I've defined them. So I need to move this. Oops. I need to move these here because I can't use them until I've set to the program what their values are. So if I do print ls, so that's called a two-dimensional list because if I want a single number from it, I need to specify 2 dimensions. Because if I write ls of 0, that will basically give me the 0th index of ls. And the 0th index of ls is another list, which is vec2. Oh wait, I've used vec2, vec1. So the 0th index of ls is vec1. So if I do ls of 0, it will print me the first one. But if I want a single value from it, I need to specify two dimensions. So I can say print the second indexed item in the 0th list. So that should print me a value of 3. Cool. And and I don't actually have to define the list in this way. What I can do is actually, in the definition, I can replace this with how I've defined vec1 and vec2. So I can say it equals that, 4, 5, 6. And just as before, we don't have to use our indexes. We don't have to index one particular number. We can still do the range of indexes if we want multiple items. So I can say, print me the first index, meaning this list, 4, 5, 6, and print me, for example, the second to the, sorry, the 0th to the second. So it should print me exclusive, obviously, of the second one. So it should just print me 4 and 5. And again, yeah, it does. So there's a list is essentially an object, and like we were talking about before, it has. Okay, yeah. So it's 2 indexes, right? So first, this might make it easier to visualize, right? So inside this outer list, I've defined 2 smaller lists. So I'm saying give me ls of 1, which means, and there's 2 items in ls, which is this first list and the second list. So I'm saying give me the first index of ls, which is the second list, right? So if I was to just print ls of 1, 4, 5, 6, yeah. And so now I'm saying, so now from that list that I've just got, I want to index the 0th to the second. So from the 4, 5, 6 list that I've just got, I want the 0th and the first one, because it's exclusive of the second one, right? So yeah, again, yeah, 4, 5. So yeah, so these lists, they're not just static, right? Once I've defined them, I can still change them. So I can do something like ls.append. So yeah, ls is an object, and we'll talk about objects and classes later. But objects have in themselves, they have functions. So ls will have, or any list that I define will have a function called append. And what append does is, like we said here, it takes in an argument, and then it adds it onto the end of the current list that we have. So I can say ls.append 7, 8, 9. Oh, I'm not printing it. And it appends onto the existing list that we have, this new array that I've put in, 7, 8, and 9. And actually, yeah. So these lists, they don't actually even have to. They don't have to hold. They don't have to hold numbers. So I can have a list of strings as well, or even floats, which are decimal point numbers. So I could say SLS, meaning my string list, is equal to my name is Haroon, and just like before, I can index this. So if I print SLS, it should give me that whole sentence like that. And if I do print, the second indexed word, so that will be is. And actually, yeah, a list doesn't even have to hold all of the same data types. So I can hold a string and an integer and a double, whatever data type, right next to each other in the same list. So lists are actually, they're very useful because it allows you to make, let's say you have many variables which are similar in some way, and you need to group them, and you can store them all in the same list, even if they're not the same data type. Okay, cool. There's also another type of, so this is called a data structure, right? Because it's just a way of storing data, storing variables, which is essentially data. There's also another data type, data structure, and that's called dictionaries. So essentially, all a dictionary is a mapping from one set of variables to another. So I can have dict is equal to, and yeah, if you look here, that's highlighted in purple, and what that means is that's a keyword that Python is already using. So I can't really use that because that means I'm overwriting some of the functionality that Python has built in for me. So I'll call it something. It's like if I was to call a variable, if I was to call my variable print, right? because then I can't use the print statement anymore. I've just overwritten it with this new variable that I've called. So so I could say my dict is equal to, and the way you do this is I can say it can map, it can map. Let's say I have a huge list of people, and they have each one of them has a name as well as an ID, for example. So I can say O, and then I do a colon to show what it maps to, and that can be like John. And then I do a comma to say that this is another. So a list, like I said, it's key and value. So this is the next item that I'm storing. So I can say 001 maps to Sally. And I can say again 002 maps to Jermaine. So if I print so I'm just going to print the dictionary so we can see what it looks like. Getting an error there. Okay, so Python's giving me an error here because it doesn't like the fact that I'm, because essentially this maps from an integer to a string, right? And an integer is just a value. So saying 001 that's the exact same integer as 1, and Python doesn't like that. So I either have to turn that into an integer of 1, or I can make that a string. So then it maps from the string ID of 001 to Sally, and same for this one. Let's see, okay. So that's telling me 000 maps to John, 001 maps to Sally, and 002 maps to Jermaine. So now I can say print me the mapping for 001. So I want to know who is the person with the ID of 001. And it tells me, it's Sally. Okay, and that's dictionaries. I'd say they're less used than lists, but it's still good to know because it can help you for certain things. Now we're going to move on to logical operators. So a logical operator is essentially, you've used it in maths, and it's things such as equal to, or greater than, or less than, etc. So I can say x equals 5, and I can say y is equal to 10. Now I can basically print the evaluation of x is more than 5. Sorry, I can even do, x is more than 5. It should print me false. Another important data type that I forgot to mention here is what's called a Boolean. And a Boolean, all it is, it's either a true or a false thing. So I can say Haroon is like 20 is equal to true. And I can just, all it does is just holds a true or a false. And that's the equivalent of calling it a 1 or a 0. So here, so I can say print x is more than 5, and that gave me false. More than or equal to 5 gives me true. And I can even, I don't have to compare it to a number that I've written. I can compare it to, another variable. So I can say x is more than or equal to y, and that's false. But these aren't the only ones. To do an equals, right? Because there's a difference between when you want to assign something and when you want to compare something. When I only use a single equals, that's called the assignment operator, and that means set the value of the first thing before the equals to the value of the second thing after the equals. So I can say here, if I want x is equal to y, and that will change the value of x from 5 to 10. But if I want to compare them, and I don't want to change the values of them, I use this double equal sign here, and that essentially means like is equal. Like it's kind of more asking the question of are they equal? It's comparing them rather than assigning them. And of course they're not equal. So yeah, so why is this useful? Because we're going to move on to something called if statements. And this allows you to kind of do more interesting things with your program, because up until now, everything in our program has been deterministic, meaning it will always follow the same route, whatever, every time we run it. So what we can have is if y is more than 5, print, and yeah, same thing here as when we were defining a function. We have to, it says everything that will be run if the statement is true is indented. So print y is big. It prints y is big because this evaluated to true. If I do the opposite and say is less than 5, it won't print that. And what I can do as well is after an if statement, I can essentially write something called else, which means, okay, so you've checked the first statement and it didn't turn out to be true. What should I do otherwise? So I say, if y is less than 5, do this. Otherwise, like it says, print y is small. That prints y is small. Sorry, y is, should print y is small, then y is big here. Because y is bigger than 5. And this is useful because we can essentially have our user, as they're using our program or whatever script we write, our variables, the whole point of a variable is not that you assign it a value at the start and then you just leave it. The point of a variable is that you give it a name and then you can perform all kinds of different operations throughout the program, and based on what the values of those variables are, you can do interesting things such as if that, let's say I'm taking in inputs from a reader like a sensor to the outside world, and I could say, oh, if this reading is more than 100, then we're getting an anomaly or something like that. So yeah, and that's if statements. That's pretty much all they are. And here you can put anything. You can even pass, in the sense that anything that can be that evaluates to either true or false. So I can put my bool. Let's say that's what it takes. So I'll say bo. That's my Boolean value, and I can say is equal to true. So I can say if bo, and all that's doing is passing in a value of true to this statement. So that means that so we can say something like bo is true, bo is false. And because we passed in the value of true, it said, yeah, bo is true. If we change that to false, it'll look here and it'll say, oh, if bo, well, bo is false, so that this evaluates to false, so it's going to run the else statement. Cool. And yeah, that's if statements. Another hugely useful thing about programs is that they can be used to automate a lot of things that we can't be bothered to do. And the way we do that is called loops. So we basically make the program perform something over and over again. Because let's say I wanted to print the numbers from 1 to 5. It would be very inefficient for me to go print 1, print 2, print 3, etc. Or let's say I had a list. I don't want to say print print ls of 1 and then print ls of 2, print ls of 3 all in a row. What I can do is I can essentially use a loop which can do that same thing of printing ls of something over and over again. So yeah, so loops. So the first thing we'll look at is called a while loop. And a while, you know, as the name suggests, it runs while something is true. So I can say while, so let's define a variable here called f, and let's set that equal to 0. We say while f is less than 10, print f. And I'm not going to run this because this will run forever. This will run for an infinite period of time because I'm not changing the value of f. I've set it to 0, and I'm constantly checking if it's less than 10, and that will always be less than 10. Therefore, it will just keep printing 0, 0, 0 over and over again. And yeah, sometimes it can make a computer crash and stuff like that. So what I'll say is f is equal to f plus 1. So I'm taking the value of f and I'm setting it to its old value added to 1. So if I run that now, it should basically print the numbers from 0 all the way to 9. Like that. I'm just going to hashtag this out. Cool. So, so yeah, again, another thing, it's a while loop is kind of similar to an if statement in the sense that it takes in here anything that can be evaluated as either true or false. So if I wanted, I can say f equals true, and then I can do f. And what that means is while true, because essentially f is true, it's essentially going to keep running over and over and that again, unless I do f is equal to false. So that will only run through it once because it will say, oh, while f, okay, f is true, so it's going to print to f, and then it gets to the end of the loop, it sets it to false, and then when it goes to check again if f is true, it's false, so it doesn't run the program again. Yeah, so that's essentially, you know, if you want to do something while something else is true or either false. Now what we can do is something called a for loop, right? Because it's kind of annoying that for me to make a counter and then increment that each time by 1 if I want it to run 10 times, for example. So Python already comes with something called for loops, and so does every other programming language. So I could say for x, or for any variable name, this is really arbitrary. So I could say for n in a range 10. So what range does is it returns us the values from 0 all the way up to 9. So you know, just like so yeah, so range is exclusive of the value that you enter. So it will go from 0 all the way up to the number that you enter, but not including the number that you enter. So if I do for n in range 10, print n. Well, let's do 5, just so we can see that it's different from the one that we did before. 0, 1, 2, 3, 4. And range, you know, just like anything which has these brackets after it, is a function. And if we want to see what that function returns, we can do print range of 5. Range not 5, but essentially range returns you an iterator item, and all that means is a list of values which you can use a for loop to iterate over. So if I was to turn that into a list, right, because like we said, we can convert it from any variable type to another, I could say list of that, and it should print me 0, 1, 2, 3, 4, and that's the list that essentially my for loop is using to iterate through. I can also iterate over any other type of list that I like. So I could say my list is equal to this is a list. I can do for, and again, yeah, this variable name is arbitrary. It's just the name that's given to the values which I iterate through. So if I just write something like for word in my list, it's going to iterate through each one of those, and each time it's going to take the 0th, then the first, then the second, then the third, and it's going to set it to a variable called word. So I can say for word in my list, print word. And it will print them in a sequence. Okay, yeah. So that's for loops, functions. Okay. So yeah, that's essentially the basics of it. Now we're going to, I mean, actually, let's stop here for a second if you guys have any questions.
So to comment out a whole block in idle, what do you do? Alt 3, is it?
Well, yeah, no, everyone's used. Okay, yeah. So, I mean, okay, if you want to like comment out a whole block, what you can use is a triple quote mark. So if I do quote 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 quote, that's in green, and basically what that means, that's just essentially just commented out, and my program's not going to read it at all. So if I go to the bottom, and let's say I'm going to comment that out, so then now nothing should be printing. Nothing prints. If you do have idle, which is this text editor that I'm using now, and you just want to quickly, like, this double hashtag thing, if you quickly want to comment out a block of code, you can select it, and if you press Alt 3, it will add a double hashtag before each line, and if you press Alt 4, it will delete those, so you can easily quickly comment and uncomment different blocks of code. Any other questions?
Not on here. No, awesome.
Alright, cool.
How's it going? Everybody, right kind of speed? You can see all the text, everything all right? Cool.
Alright, awesome.
Shout or let me know on the chat otherwise.
So, so now we're going to talk about something called classes, and these are really important in programming because pretty much a lot of modern programming is built on object-oriented programming. Okay. So object-oriented programming works like this. You define something called a class, and this class is essentially a template for a type of object that you want to use a lot of. So let's say I've got like something in my program called human or car, right? And I want to create many of those to use in my program. What I can do is I can define a class. I can do class car. And in each class, you have to define something called init, which is essentially you have to do def, and then you have to do double underscore init. And then, yeah, and this works like just any other function. This just means whenever I make an object from this class, from this template that I've created, what function should I always run? Like, for example, what things do I need to know about a car when I first, if I want to create a car object?
So that initializes the car object.
Exactly, yeah.
That's what init means.
From classes, you create objects, any function inside a class takes in self as a parameter. I'll explain this later, but just like ignore it for now. So I can say, okay, for my car, each car that I enter, I want a a brand, and I want like a year, and that's the year that it was manufactured. And then I can say, because each object is essentially self-contained, each object is built up of functions and attributes, and that's essentially things that it can do and properties about it. So in a car class, I might have something like, I might have the attributes of number of wheels, model of it, year of it, etc. And some functions of it might be start driving or stop or brake, etc. So what we can do is we can set the attributes for every object that we initialize. So we can say self dot model.
So self means you're talking about this instance of a car.
Yeah. So we'll keep it very simple for now, right? Not model. Self dot brand is equal to brand. Self.year is equal to year. Okay, so we'll just begin with that basic simple class, right? So let's say I've got a car now, and I want to create a car object. So I can say something like my car is equal to car, and then I pass in the parameters that are required for initializing it, brand and year. So I can say my car is a Ford, and this year was, the year that it was manufactured is 1980. So this car is now a self-contained object. It's essentially, we have this template for something called a class, right? We've defined here, and now we've created our first object from that template. So I can do print my car dot year, and what that essentially does is every car has attributes, like we said, right? So it looks inside my car object, and it says, is there an attribute called year? And here we have defined self.year. That means every car that we define has its own year and has its own model. So if I do my second car is equal to car of, and let's say this one's a Tesla. It was created in 2016. So if I do print my car.year versus print my second car.year, what it will do is it will print the individual years for each one, which is defined by self.year. If we print that, 1980 and 2016, as we defined here, because that's the values we passed in. So what's essentially going on here is we're saying my car is equal to car, and in as parameters it takes to initialize it takes brand and year. And what it does with those values that I pass in, it says for each individual car, its own brand, like self.brand, it's referring to this object. So it's saying my car.brand is equal to brand. So, or in this case, like my second car.brand is equal to whatever I pass in here, which is Tesla. So yeah, so the whole point of the self thing is to allow you to essentially make many objects from a certain template, and each one of them has their own individual attributes, so then they're not shared across them. And self essentially is kind of like passing in its this object as a parameter, because every time I call okay, I'll explain it in a second once we've developed this class a bit more. Is everyone happy with that so far? What are classes and attributes?
Can you explain self a bit more?
Yeah, I'll do that in a sec. So okay, so now we've got some attributes in our class. We can say what are some things that cars can do. We can say def, like define, just as before, start, and it takes in a parameter of self. We can say if self.year is less than or equal to 1990, then we can define a new attribute here, right? We can define an attribute at any point we want. So we can just say something like self.state is equal to stalling. And what we can actually do here is once when we initialize the call, we can just give it an initial state of like self.state is equal to parked. And yeah, so what this is going to do now, if we do else self.state equals going, and we can do print self.state. Okay, cool. So now I've created these cars, and I've defined their parameters, and now I can say my car.start. And just as before, because this is a function, we have to do this after it. And this doesn't take in any parameters other than self, and self is automatically passed in, because what self essentially means is that I'm referring to the values for this particular car, and every time every time I run start, right, I need to know which car I want to apply this function to. So automatically, whenever I call it, passes in itself as an argument. Does that make sense? Do you think? Okay, cool. So if I do my my car.start, it's gonna go into here. My car is gonna do start, and it's gonna say, this car, like itself, is gonna say if self.year, referring to the car that I've defined there, my car, it's gonna say essentially my car.year is less than or equal to 1990. Then set the state to stalling, otherwise set it to going, and then print that state. So if I just go for that, it will say stalling, because the year of the car that we defined here is less than 1990. Okay, cool. And yeah, so I can do the same thing for my second car dot start. Going. And we can define many more things in here. So we're just going to do a quick interactive thing. I want all of you guys to make a new function for inside this class called stop. And what I want to happen when you call stop is to set the state of the car to parked again, and then print the state to show that it's parked. We'll just take a couple minutes out for that. That's a good, I mean, yeah, I'd say, the more you program, the better you get, like anything. And it's just about, I'd say, over the next week when you do, if you do want to be really prepared for next week, because obviously we are going to dive in and we're going to start with machine learning, I recommend just think of little programs, little things that you can do as a little, like, calculator, or a number that, a program that calculates the Fibonacci sequence, or some just little programs like that, and just set yourself little challenges and keep doing them, and you'll get good really fast. So so we don't have long left, but in this in these last 10 minutes that we do have, I'm just gonna quickly cover the basic functions of what we're going to be using a lot over. Well, it's basically going to be the main library that we're going to be using over the next 4 weeks. Yeah. So. Does everyone know how to install Python libraries yet? No. Okay, so are you guys on? Is there many people on Windows? Okay. Okay. So if you guys.
Send out a tutorial for that, unless you want to go through setup environment.
Okay. Yeah. So I'll send out a tutorial for how you guys can get NumPy set up, and then you guys can have a look at this. In your own time. It's literally really quick, but I'll basically show you what you can do with NumPy.
So what you want to do is import functionality from other code which other people have written. But when you import functions, Python has to look for them somewhere. So it looks in a place where it's searching for the environment variables. It's looking for that path, but you need to do a whole setup to find that. So we'll send you out a short tutorial just how to go through that, but we don't have time to cover it now. It's not difficult, but it just means that you can do things like import NumPy as NP.
So yeah, in Python, as in all programming, one of the huge bonuses is that there's huge repositories of code out there that people have been working on for years, and they've been optimizing them to work as fast as possible, and have a load of functionality. A very important library in Python is called NumPy, and it's basically a general computational library. And it sounds complex, but all that means is it can allow you to do a lot of different operations, such as matrix multiplication, or dot producting vectors, or any kind of mathematical function you could think of. You could probably do it in NumPy.
But in a really optimized, computationally efficient way.
Exactly. Yeah, because it will be really annoying if you have to work with lists. They're just, they're quite slow, and they're not good if you want to do mathematical operations. So the way we import external libraries to use in our code is we go import numpy, for example, and what we can do is, and every time we want to use something from this library, we have to do numpy dot, and all numpy contains is a series of, you know, functions like we've just seen, and objects, like classes that we can make objects from. So it has an object type called an array, and these are, you know, really fast for doing computation on. But every time I refer to those functions, I don't want to have to write, you know, type out the whole thing numpy. So what Python allows me to do is I can say import numpy as np. So that means that whenever I want to use something from numpy, like if I want to use numpy.array, for example, I don't have to write that anymore. I can just write .np.array. So it just kind of switches out the name. So yeah, so main thing in NumPy is arrays or matrices. So what we can do is we can say, or we can actually just say vect, or vec, which is a vector, is equal to np.array, and then it's a function, and it takes in the arguments of a list. As argument, it takes a list. So I can do np.array of 1, 2, 3. And if I do print vec, it will say yeah, so that's a NumPy array there, 1, 2, 3. It looks essentially the same as a normal list, but if you look closely, it actually doesn't have the commas, so it's not actually a comma-separated list. It's just a vector. And just like before, we can do multi-dimensional lists or vectors. So we can have vectors within vectors kind of thing, and that's essentially a matrix. So we can say that is equal to np.array of and what that's going to do is it's going to create for us a 3 by 3 matrix with the values ranging from 1 up to 9. Oh, yeah, I've just done a dot there instead of a comma, so yeah. And yeah, so that's essentially the basis of NumPy. That's the main useful thing from it, which is this type called an array. And what I can do is I can, just as before, I can index it. So I can say 0, and that just means the first row. 1, 2, 3, because that's the 0th thing inside it. Just as before, I can do 1. And but a good thing about NumPy is it allows me to slice this matrix in an even more interesting way. So so what I can do is I can get something like 1, 2, 4, and 5 if I wanted, which is something you can't do with normal lists. So I can say print me. I can say something like, okay, I want 0 to 2, so that's going to give me the 0th and the first, sorry, 0 to 2, so that's going to give me the 0th and the first rows, and yeah, so I say comma, 0, 0 to 2, and that will give me 1, 2, 4, 5, because it's giving me like 0, the index is 0 to 1 in this direction, and 0 to 1 in this direction, 0 and 1 in that direction. And yeah, that's not possible with using normal lists, so that's a very useful functionality to have. And as I was saying, you can do operations on it. So I can say print 2 times vec. Oops. That will give me everything multiplied by 2. Something else I can do is matrix multiplication, which, you know, it would be extremely long to say, to do a for loop over all the items in a particular list and say, yeah, times this by that, times this by that, times this by that, and then add it, right? So I'll show that in a second, but I just want to quickly show, yeah, so I can even do something like np.sum, that, and what that does is np.sum is a function which takes in as argument an array, and it outputs me the sum of all the atoms in that array. So the sum of numbers from 1 to 9 is 45. So yeah, so now let's do, let's call this mat. Now let's do a matrix multiplication. So we can do a matrix multiplication of, for example, let's call vec is equal to np dot array of 0, 0, 1, and I can do print np.matmul, and matmul is a function which takes in 2 parameters, the first matrix and the second matrix, and it just outputs you the matrix multiplication of those two as an array. So I can do np.matmul of vec with mat. That prints me 789, which is the matrix multiplication of, of this with that. Just out of curiosity, how many of you guys are familiar with linear algebra and matrix multiplication and those kind of concepts? Okay, that's good. It's going to be very useful over the next couple of weeks. So yeah, I guess we can end it there.
But we are going to have a continued drop-in session for the next 30 minutes before Into Deep starts. But yeah, thanks a lot for all of you for coming. I hope you enjoyed your first session. Probably was a bit slow, but you know, we just got to make sure everybody is up to date and up to par with Python and on the same level.
And yeah, and one thing I'd like to say as well, you know, one thing we really like about the whole programming community is the openness of it and the fact that everyone likes to share and help each other out. So don't use that WhatsApp just as a way to ask us questions. If you guys have questions, you know, post it and make sure you check and try and help other people out if you get something that no one else does. Yeah, I mean, programming is built on the open source community of, you know, developers who just do it for free and want to help each other out. So yeah, so just, you know, share the love.
Yeah. Also, yeah, we're around all the time, so if you've got any questions that you want to ask us or just want to talk about whatever, just come and hit us up. It's absolutely fine.
Yeah, thank you guys for attending the first time on Wednesdays. Cheers.
Yeah.
Thank you.